But I'm Reed Whittington, Denver Pierce. We're out of Dallas. Mic check. Okay. So we're with Burns and Mac engineers, Burns McDonnell Engineering. We've been around for over 100 years. Kansas City headquartered. We've got some team members here, and Denver and I are out of Dallas. And we've been working around with 3D and BIM and lots of use cases with engineering use cases. And who went to the pub last night? Anybody? Yeah. Who's? I meant to come and have dinner with you guys, but I ended up having the data bar for dinner. You're supposed to laugh. The data bar is very good. Okay. So again, we're a team of pipe fitters. I'm sure you all can attest to that, Matt. And I just want to thank Safe Software, Don and Dale, for all the support over the years. Ryan, who else we got? So I'll speak into the mic. Yeah, we're part of the technology consulting team. We're basically the data engineers. We support over 5,000 engineers, structural, mechanical, electrical, and mainly civil. And our bread and butter these days seems to be electrical transmission lines going across multiple states with very large structures, and we integrate it all mainly with FME. So we've got the basis of what we think is the key technology to sharing 3D content over the web. Who's used WebGL? Anybody use Google Maps or GLTF? All right. And Cesium. All right. Well, a few years ago, Google announced that they were discontinuing the Google Earth plugin, so we started fooling around with Cesium as a replacement for the global Google Earth. And we've always used FME as sort of the data pump, the engine that keeps moving data from CAD systems into the web, into our web browser. And we start out typically with what used to be a little ugly, little painful process. And sharing the data over the web was, we'd had to jump through a few hoops. Usually it involved exporting CAD files to OBJ or Collada and converting with external utilities. I think Denver can probably attest to that. It's a little ugly.
Yeah, I'm 5 years older because of all that stuff. Yeah, I'm actually 48.
48. Yeah. Well, I got you beat there.
Yeah, but we use FME to just none of my like the engineering coworkers here, so I can say this: we're garbage men. Like they give us garbage, and we give them clean garbage. Like we're recyclers on a good day. On a bad day, we're just garbage men. But we push. We use FME to push a lot of this stuff around. They give us, their trash, and we clean it up using FME. FME makes all this possible to take in formats like the previous presenter was saying with Revit, AutoCAD, GIS, CSVs. I once georeferenced a camera phone picture of a napkin. So I mean, like all kinds of weird data. For napkin is not a data format that's supported by FME, but we made it work.
It does work.
Yeah. So yeah.
And we, I I like the terminology that they used this morning, the pipe fitters. And I wrote down some things. When I came from military flight simulation background, so I don't know how I ended up with a construction management company, but when I heard routing and ports and engines and networks, you know, I'm thinking in technical terms. Well, we've got networks of electrical distribution, networks of water, gas, airports. Routing took on a whole new term for me. And engines, power plants. So that's my little plug for the engineering domain. So who uses these two new writers that are in 2017? We've got GLTF, 3D tile sets, point cloud, or our building model. Okay. So explore this in your own time, but these are really what excited us to experiment with some of these use cases. What we had done before in the past is we went through all those hoops, went through OBJ or went through Collada, and now we can bypass all of that. And I've heard GLTF called the JPEG of 3D. Does anybody agree with that statement? And Cesium, I like to describe it as sort of the WMS, TMS of 3D. It's basically the metadata that describes your tiles in 3D in a geocentric coordinate system. So it's true 3D Earth. And as a matter of fact, that's the coordinate system that we fly our satellites in. So it's good that we don't run into the Earth. And there's 3 flavors of the GLTF. Experiment around with it. So just a little contrast with the way we used to do it. We used to have to, of course, export to OBJ, DAE, and go through either an external mesh simplification or other external tools. And we'd slice and dice the models, and we had limited automation. And it was hard to put this on an FME server as well, because all those third-party tools sometimes don't play well on the server. So now we can write directly to GLTF, GLB, and magically handles the mesh conversion from the solids into mesh. So the tessellations happen. There's still some things we'd like to see, but it's a very, very good start. So it creates a very efficient hierarchy for the 3D tiles. And we have several use cases that we have proven over the years. As Chris was pointing out, the Revit use case is very much in the architectural and building planning. But our bread and butter is PLS, power line systems. So we all know FME is great at doing GIS, CAD conversion, and database. But now we can go directly from the Inventor models. That happens to be DWG, but it has all the solids in it. And we can, what I'm doing here is just filtering on some the bounding boxes and taking out parts above ground level. And then going into the coordinate system, but going directly into 3D tiles. And it saves quite a bit of time. And so a little more about this. This is a little kind of a pattern I like to use with running successive iterations over your data set. So when we generate the first set of tiles, I can give it parameters to keep everything above that half a meter, filter out bounding box of 0.3, And then I'm fooling around with the number of features per tile, kind of works. And then we generate the Z offset. So a lot of times we'll run this twice with 0 offset and then pull it up to the accurate terrain. And the run modes go through a successive iterations over the data set. And then eventually we optimize and then we upload to the S3 buckets. So that's what this part does here, the optimize. It reads back in the B3DM, and then with the text writer, writes it back out to a zip file, basically a zipped up gzip with the feature writer. Just takes that file name. And then here, this is actually a trick I did the other day using the feature writer. You can chain all these things together. You used to have to do it kind of externally and with some Python. But now you can actually do chaining in your workspace. And sorry, Don, this is more than 10 transformers, but it's very good. Anyway, then down here we just upload to S3. The new S3 uploaders allow us to set the header, the content type, and the content encoding to gzip, so that really helps with the download speed. And I'd run this, but it takes like 10 minutes. So here's the output of that workspace. 8.6 thousand solids and surfaces. That's untessellated. And here's a GLTF model. This started out as about a 10 meg KML file. And again, prior to 2017, we had to do some custom Python and library scripts in order to get it up to the S3 database. And name connections really help, so use name connections for your deployment. Now we're going to go into a demo. Do you want to do it on here?
I'm gonna hot swap this over. If anyone's watching Netflix right now, stop. I need the bandwidth.
Want the
No, I'm good.
Ethernet?
No, don't do it.
No.
Okay, so as it comes up, oh my God, I hit too many buttons. So what this allows us to do is the engineers, what they think is a large data set on the internet is a extremely large data set. So this is, the one I'm showing right now is an example of a parametric design for a substation. What they'll do is they'll design all these little bits, all these little parts, and they'll design all those parts to an extremely high level of detail. And I'll zoom in here in a second and show it. And then they just copy and paste that part everywhere. And they maintain this all in a model, so then when they go to actually build the thing, they know how much everything costs because it's all associated with parts and everything. The downside is that when we export it, it's like gigs and gigs and gigs of meshes and information and all this stuff's in there. And a lot of websites, you put a couple megs into a website and it's gonna die, like a horrible, painful death. We tried it a couple times before we had this writer. We were trying to export stuff to GLTF and do all these little hokey little tricks to make it all work. But then with 3D tiles, the specification came out that's been finalized, or it's kind of going through its finalization. Came out, we're like, oh, this looks cool. How do we make any of this stuff? So we dorked around for a little bit trying to make it ourselves, and then we found out about the writer, and we dumped all that stuff, like literally threw some of that stuff in the garbage, and moved on to this. So SAFE has allowed us to kind of take some of our existing tooling for reading in these data sets and dump them back out. So as you can see here with this substation, If I come in all the way, I mean, we're getting down to literally, actually, we did take the bolts out.
we filtered out-
It's not nuts and bolts. We took the nuts and the bolts out because we were like, you can tell there's a hole there, but it's everything but the nuts and the bolts. So if we come down into some of these pancake grills or whatever the heck these things are, I'm not the engineer. I just make the engineers look good. The insulators and the shields and all the stuff, the cables, all the stuff. When they see this on the internet, I mean, the engineers, they just nerd that. They nerd the heck out, man. And what we found with our product is that if you go to a meeting to show them and talk about what you want to do, and the meeting will get completely shut down because the engineer nerds, they just go crazy with this stuff. We'll just sit in the back and they'll go nuts on it. I mean, a lot of times they actually have a lot of difficulty visualizing their designs and stuff, especially in a shared space or kind of a shared environment. So what FME, OneTouchPM, which is our product, and 3D tiles and all this allows us to do is really just dump in just like truckloads of data. Cesium in the 3D tile spec handles a lot of the rendering on the fly. So everyone got off Netflix, so it's kind of coming a little bit faster now. You can kind of watch, if I go to a new area, you'll see kind of the details come in. But this is
Don's data set.
Yeah,
It's on a S3 bucket.
Yeah, this one I think came from a 3D city GML, I believe, from the city. Okay, here's LaGuardia. Someone was doing the LaGuardia one yesterday. There's a little bit, it's not as good as geometry as the previous presenter, but there is some stuff in here you can kind of see. We've also got this one. I'm only allowed to show you one of these, but we have like 100-something mile line, transmission line of all of these. This just allows us to get way down into the detail levels, and Cesium handles a lot of the, this one? Oh, you're right. It just allows us to get down into a lot of the nitty gritty of some of this stuff, which we weren't able to do before. I mean, previously we'd be showing just polygons and, amalgamations or different just ways of just aggregating the data in. Now we just throw the whole thing at the browser. And it's worked out extremely well for us. Previously, we were burning a lot of time just trying to get this stuff in. It was a very manual process, like Reed said. We had weird command line scripts. We had duct tape. We had there's a little blood sacrifice sometimes. Just whatever you got to do to get the data in. But now our process has gone from like a crazy mess of transformers to just these new writers, and the new writers are working out great for us. We worked very closely with SAFE to kind of beta them and find a lot of the issues and stuff like that. It's gone extremely well for us. So
and we'd like to keep talking about the improvements that are required to really build this out, the 3D tile set, and some of the next steps. There's 3D tiles planned for vectors. And
right, yeah. The 3D file specification has a ton of stuff, and I'm sure like every time a new one comes out, we're gonna emailing SAFE like, hey, is it done yet? And they're like, man, we just finished the last one. So we're always pushing the cutting edge on a lot of this stuff, just because we handle and manage a lot of weird large data. And the engineers love it. So this particular, like this, not this one structure, but the whole transmission line, we've been able to make the review process substantially faster. We used to do something like a 1-week turnaround on the design. So when an engineer kind of finalizes where a structure is and how big it's going to be and what have you, we would say once they've kind of they hit save on that file, then to go and show it to the client or any stakeholders or the Bureau of Land Management, anyone like that would say, okay, we're going to need like a week to kind of run all this stuff. It's going to take a couple hours just to run the translations. Now we're doing those turnarounds in about a day or two, I believe. So the new writers 100% facilitated that. So we're able to kind of speed up that whole land acquisition, surveying, environmental monitoring. We're speed up that process because as soon as someone says there's a problem with the design or we need to move things or we just want to look at stuff, The engineers make the changes, we process the changes, and then we're able to go right into a meeting with everyone involved and say, hey, here's the new design, or here's what we're proposing. We've been able to speed up this process immensely just using a lot of these new tools. So does anybody have any questions, or we got about 5?
I got one last slide.
Okay. Reed's got another slide, but if anybody wants to,
Questions, please.
think about your questions.
Please.
I want good ones. What do you got?
You mentioned the file size on the old KML that y'all used to do.
Right.
What kind of file size improvements have you been seeing with the Cesium?
So file size improvements, actually, I would say the individual files, some of those, the substation one, actually those tiles are coming at like a meg, which is pretty big. And there's a lot of them. I mean, there's a ton of them. What we've seen though, it's not the issue with the actual individual file sizes. I've tried to throw some really big files at and just literally like, actually orange screened my computer, which is like, if you've messed up if your screen goes orange.
And the size of the source data is an issue, and we've had to go to 64-bit
Right.
FME for that and ramp up the RAM. But it handles it pretty well. Sometimes
Right.
we have to slice and dice things. But as Denver says, the 3D tile spec is such that you can chunk your data very easily.
Right.
And the file size is still an issue. There's some work to be done there to control the file size of the chunks. But you weigh that against a bunch of files. You know,
Right.
Would you rather have a 20 meg file or 21 meg files that still take a long time to download?
Right.
You might see it populate in front of you. So
Yeah, so the main thing with the file size hasn't been a big deal. It's the fact that the Cesium render and the 3D tile spec is based around levels of detail, so you're not always loading the highest level of details, and then cycling tiles back out of memory, or just dumping them if you've zoomed in all the way really quickly. You know, you may zoom out and have a really low detail zoomed out tile, and then you'll fly in really quick, and the renderer will just give up on some of the mid-tier tiles and throw them out. What we were finding with the old KML way was we were trying to shove in, 500 megs of tiles and just leave them all in there. And actually the GPU RAM would completely fill up, and the reason it would go orange was because the OS just couldn't fit in there anymore. Even the OS couldn't render. But with the 3D tile spec and the way it's all chunked and everything, stuff will come out. It'll come back out of memory, and the renderer is smart enough to know when something's important and when it's not. Because you want to go to your last slide.
The LOD scheme is basically the LOD scheme is very different on Cesium, and it actually works quite a bit better than the regenation that KML had. But you can convert your Collada models into GLTF. You can read them directly. But here's some next steps. We're going to keep working with SAFE to hash these new formats out and continue to throw more CAD data at the writer. We're kind of in a good situation because we have all these use cases, and most of the data is pre-processed into the FFS files, so we only have to change the back end. Where it, would write to Collada or OBJ, now we write directly to GLTF and the tile set. So point clouds are also supported. That's probably another talk. We've fooled around with that quite a bit and had some really good initial results. It'd be nice to have the gzip built right into the GLTF writer. Most writers have that, and so we'd want to be able to control the extension basically. So we didn't have to do that extra step. It'd be nice to have more control over mesh simplification, and also to control the tile size. And we'll continue to work with the Cesium community, with AGI. Denver's very involved, and they're of course working with OGC and Kronos. So we expect this standard to evolve and benefit the whole community.
Another question right here? Yeah, just dump them on S3. It's JSON or
In the latest version, FME 2017 version of the S3 uploader, you can set the content encoding.
oh, awesome.
Yeah,
Yeah, I think we had seen that. Yeah, yeah.
Right, we do that. But, you know, you always have to work on your local disks at some point, even if you're on FME
Right.
server, and then upload them.
Probably have time for one more question. Anybody in the back? We've done a little bit of textures. Coming from Collada, if we use the Collada to GLTF converter, they go over pretty well. Sometimes they have weird transforms. They don't work quite as well. But if they're pretty average, if they're pretty normal textures, nothing funky and weird, they'll come over. Lighting, some of the other weird stuff like lighting and some animations we've had a lot more problems with, but those aren't really like main parts of the spec. But yeah, they'll come over. I'll tell you one more. Sure, why not? Hit it.
You said you PLS-CAD, do you actually read from the PLS-CAD? Or you actually-
Yeah, I'll let Reed take that one.
Yeah, what do you think? Yeah, we read the KML, the export from the KML, and it's become a challenge because even Google Earth can't load those models sometimes, so, but FME can. It's very good. But we're glad to talk to you guys offline and show you more. We've got lots in OneTouch into this demo website. We've got textured models, point clouds, laser scans of ground terrestrial laser scans, and quite a bit. So please talk to us and reach out. We look forward to meeting with you and talking more about Cesium and 3D tiles. Thank you.